Hey guys, and in case it didn't start recording at the right time, hey guys, I'm back. This time I'm going to go ahead and do a Khan Academy task from the last section, Applications of Integration. And I've got several things set up on my screen, so we'll kind of work through it. Lower this out of the way, kind of. So anyway, I'll post this. You're seeing it now because I did post it. And I'm going to go through the concept that I think I've got confirmation from CW, that is on the final. I posted some information about when they would start registering for the final, for the class. I should just start over. I'm not going to. All right, so anyway, you're watching this live-ish. Once again, as I share new information, stop and pay attention. If I'm saying something you're like, no, I got that, just skip to the answer, get to the answer, get to the end. Go ahead and scrub the YouTube bar across the way. I'm going to minimize this. I am using Zoom for some WSU classes, and I really like that little pop-in because you can see me. I hope it all records really well. I'm just trusting my setup is still good. And anyway, let me get to where I'm at. I'm in AP Calc AB. I'm in Applications of Integration, and I've worked through all of these, but I haven't yet started volumes with cross sections, squares, and rectangles. And that's a tough one. We did a little bit of this, if you remember the wedding cake design on one of those questions. But now instead of having 5 layers, we've got an infinite number of layers. And we need to look at kind of some examples to get a picture of what's going on. I'm going to use Desmos for my calculator. Yeah, because I don't have the other calculator. My computer got wiped, and so I had to reset everything. So, all right, the base, I'm going to use Desmos for the graph. Okay, let me read it. The base of a solid is a region enclosed by the graphs of y equals sine of x and y equals 4 minus the square root of x between 2, x equals 2, and x equals 7. Okay, so I'm going to visualize this by going to Desmos first. Desmos. You can skip ahead until the part where you see that I've got graphs on the screen, or suffer through the finger clicks on the keyboard of the noise that's made as I type everything in. No prep went into this, sorry. Okay, I don't like y equals. I'm going to go f of x equals sine of x, and g of x equals 4 minus square root of x. Oh, they even limit it from 2 is less than or equal to x is less than or equal to 7. And let's see if I can copy that. If you don't know how to get the less than or equal to signs, the little keyboard down here pops them up, and there they are, so you could type them instead. So this region over here, let's go projector mode, nice and bold. This region right here, we want to find the area. If you imagine a rectangle, rectangles whose height is 2x. We want to have a rectangle that's formed here. So this is where my graphing skills need to be translated to paper, and then I can put some like space on them. Again, feel free to slide, scrub, do whatever. Custom this so that I can custom it this way. And we're zoomed out. It might crash. Oh well. You see my hand, large and bold. There it is. So we've got our graph. What's up? It kind of does a little bit of this, and then there's a little swoopy swoop. And so if you imagine that a rectangle is built right here, and so it actually stands up off the page, and everywhere, going straight vertical, vertical, vertical. All of these are little snapshots of a baseline edge to the rectangle, and then it rises up, and we get this 3D shape. Gosh, I don't even know how to describe the 3D shape. It kind of has this angular look, very you know the design of the EMP building in Seattle, kind of like how it looks all amorphous and crazy lines and whatnot. It still has this rectangular. So there's still 4 edges. There's the top face, and then the side face. Underneath is the bottom. So just really try to wrap your head in the hideousness of my drawing. Wrap your head into being like a 3D shape. And that 3D shape is popping up and out of the page, and so it's rising up and it's still following this like thing. But every single, do I have a different marker? Pink. Real men wear pink. Every like little section is a rectangle, and there are just several little like 3D rectangles stepping up like off the page towards you. And so that's what I'm trying to like represent with, again, that hideousness, that there are those rectangles that are there. Let's get rid of that. So for me, there's more detail to this problem. We're talking about volumes. Remember the formula for volume. Volume is base times width times height. Base times height times depth. I don't know, however you define it. Length and width and height. It's just three things that you're multiplying though. The thing is, we're taking the length and width. This dimension is going to be completed using the integration along dx, because the depth is, I actually need that. Oh, rolly chair. This depth is like sideways, so like we're stacking up in this direction, height or depth, however you want to refer to it, stacking up layer upon layer upon layer upon layer, in just all of these layers of a piece of paper, a rectangle stacked, turned sideways, and we want to know their volume. Calculus is the only way to really do this effectively, efficiently. Okay, so I'm going to look at my answer choices for a second before I kind of get lost in the minutia. They all go from 2 to 7, and that should be obvious because we're saying from x equals 2 to x equals 7. They all go, let's see. Okay, this is the tricky part. When I drew this sketch, or when I looked at it with Desmos, there's this top function and this bottom function. The top function being g of x, so that is 4 minus square root of x. And it's contained to the x-axis. If we integrate just g of x, we're going to get the area that goes between g, the blue function, and the x-axis. If we integrate the red function, we get the same thing. Some of it will be negative, but ultimately it's all what's contained between the function's curve and the x-axis. We want the space between them. So if you haven't watched the previous video, or if you haven't practiced it, one of the previous concepts is on the area between curves. That sets up being successful now. So we need to take the g function and subtract it by the f function, so minus sine of x. And this image, or this value right here, in fact, I'm going to put that up, the integral from 2 to 7 of, this is why I love using g of x and f of x instead of y and y, I get an answer. If you were to color in this little space right here, I hope my screen and my mouse are showing up. If you were to color in the space between blue g of x and red f of x, it would have an area of 10.709. 7088, etc., round to 3 decimals, 709. So this is like our area of the base, and maybe my picture with all these lines is not appropriate. Maybe instead of the lines looking like this, the lines are actually sideways, and we're placing paper upon paper upon paper upon paper, and it stacks up, showing you on the screen, stacks up to create a volume. So our first edge looks like this, and then on top of that, we're going to tack on another layer that looks maybe a little bit different, but not quite different enough. And we just keep stacking it until we have this 3D shape that has 4 edges in the same direction, a front face that's a rectangle, a back face that's a rectangle. And if you kind of look at it like on the side, it'll still look like a rectangle. Maybe it won't even look like a rectangle yet because there's that 2x piece of information. Let me go back to Khan Academy question. Cross sections of the solid perpendicular to the x-axis, so that's my pink that I'm drawing here, are have a height of 2x. So wherever we are, oh, this thing is growing. So it looks maybe from the side something like this. That's its cross section if it was like a building rising out of the ground in front of you. From the top, it looks like this. So you're looking down from a surface level, you see this. From the side, you see this shape because the height is growing by 2x. So all of these rectangles, I'm just drawing the front edge of the rectangle, all of these rectangles add up and you have your total volume of the shape. Again, I'm drawing this, my ability to communicate this as a 3D image is really sparse. I'll try to find a better video, or maybe like you should go look at one of the other example videos. I just want to answer the question. Remember this though, it is area of, let me go this way. The volume is the area of the base, as in this is length times width, times height. And from the formula, if I take the integral from g of x to f of x, again using my Desmos notation from 2 to 7, this is my base area. So I have that component, and then I have the height component, which is as we move along the x-axis from 2 to 7, the height becomes 2x. It grows by the function 2x. So putting it all together, swap that, push that into there. I'm gonna go with B. Okay, if I'm wrong, we'll figure out why, and I'll record it and share with you why I'm wrong. But so far, I've been able to convince myself the answer is B, because volume is base times height, or area of the base face times height. And when we're talking area with calculus, we're talking about integration. So there has to be an integral, and go to that previous example on area between curves. Yes. Okay, I'm going to answer another one. If I get another one like this, I'm going to leave it alone. But anything that's talking about squares and rectangles, the volumes of cross sections with squares and rectangles, is really using this volume formula, length times width times height. It's just that length times width is that's an integral sign. It's the area between the two curves, and there has to be some sort of way they describe the relationship for h. Maybe it's stuck at 10 and it stays 10 consistently, or maybe it grows by a function of 2x, just whatever that sort of relationship is. Okay, keep the video short as possible, so thanks for watching. Comment, like, subscribe, ring the bell, notifications, and I'll see you on the flip side. Pause the video.